Okay, well let's work this one. So we want to find all of the zeros of this polynomial, and then we want to factor it over the real numbers, and then factor it over the complex numbers. So, wow, looking at this, it doesn't really look that great. Let's rewrite that. So this is 2x cubed minus 5x squared plus 6x minus 2. Okay, that looks a little better. There, now it's gone. Okay, so we want to just find the zeros first. Well, if we can't immediately see a factoring technique that we want to use, we should fall back here on that rational zeros theorem. So if there is a rational zero, then that means that it's got to have a certain form, right? And we're looking to those coefficients out front. So I'm going to try to construct these things. For my values of p, I'm looking at the constant term. So I want factors of 2. So those are 1 and 2. Q, the denominator, I may be looking at factors of positive 2 again, so this is just 1 and 2. Okay, so this tells us that plus or minus P over Q. I'm only going to have a few things in my list, right? I've got 1 over 1. I've got 1 over 2. And then I've got plus or minus 2. And then plus or minus 2 over 2, but that's still 1. So these are the only rational numbers that I'm going to have to check. We know that if we find a single one of these that works, so if we find one of these is a 0, then we're going to have a quadratic, right? If I divide a cubic polynomial by a linear polynomial, which is what we're about to do, then the quotient would be a squared polynomial. So that would be quadratic. And we have really, really quick and easy and tried and true methods of solving quadratic equations. So anyway, let's start find this 0. So I'm going to let the cat out of the bag. I did this ahead of time, so I already know that these aren't going to work. So in your work, do these and find out whether or not those work. But I know from my proper previous preparation that 1/2 is going to work. So let's do that. So maybe pretend that we tried this for 1, but you know, show that it works or show that it doesn't work. So we're putting all of our coefficients here. We're going to do this synthetic division business, right? So we bring down that number and then we multiply. 1/2 times 2, and that's going to go here, so that's 1. We add these, we get -4. Multiply again, 1/2 times -4, that's going to be -2. We add those together, we get 4. We multiply 1/2 times 4, and we put that there, we get 2, and it's 0. And, you know, big surprise. I went ahead and did this ahead of time, so I knew that this was going to work out like that. Anyhow, we can now rewrite our original polynomial, that one, as a product involving what we just found, right? Since this is 0, this means that x minus 1/2 is a factor, right? Because the 0, the remainder is 0 when we divide. And we know that when we divide by a number and we get a remainder of 0, that means that number has to be a factor of the dividend. So anyway, we've got x minus 1/2 in there. And then the quotient would be, this is again a quadratic. So we've got our constant term, our linear term, and our squared term. So I've got x squared on that one, x on that one, and then just 4 there. So something that we ought to do just right away is take this guy and see if there's any common factors, because in this case there are, right? I've got a 2. I can take out all of those, so we can rewrite this. X squared minus 2x plus 2. All right, so now that we've got this as a product of a linear term and a quadratic term, we want to, well, go and factor it further. So what we might want to do is, now that we have this reduced to a quadratic and a linear, we can try to find where this is 0. A little bit of exploration there is going to show you that we're only going to get imaginary zeros out of this thing. So maybe we can go and explore that. So this, if I wanted to go and find zeros of this guy, I'm going to solve where it is 0. Well, if that's true, we have the quadratic formula, right? We know that -b plus or minus the square root of b squared minus 4 times a times c over 2 times a. That has to be our x, so that means x is going to be 2. We're just going to do a bit of simplification here, right? So I've got negative 2 squared, that's 4. Negative 4 times 2, that's 8. Okay, and we're still playing the simplification game here. 2 plus or minus, what is this, square root of negative 4. So that's 2 plus or minus 2i. So now we found our additional zeros here, right? So the only zeros of this quadratic, we found them using the quadratic formula. So in order to write this as a product of two linear factors, we would have to use complex numbers. So this is factored over the reals. So this is factored over the reals, because we factored it as much as we could using real numbers. So there's going to be a little box in your homework that's going to say factor this over the real numbers. And there, we've done it, right? We've only used real numbers to write this out. So we will want to factor now over the complex numbers. So we can do that because we know the zeros of this, right? So if we want to go and rewrite our function yet again, we can write it as x minus 1/2. Well, we have that 2 in front, didn't we? 2 times x minus 1/2. And then we can write our, this quadratic factor, we can write it as a product of two linear factors using these zeros, right? Because we know that x minus this one has to be a factor because this is a 0, right? And then x minus this one has to be a factor. If you really, really want to, you can go a step further and subtract that, but I don't think you need to. The computer, I think, will accept it either way. So anyway, we can write this just to write exactly what I'm saying. We can distribute that if we want to. Minus 1 minus I, and then x minus 1 plus I. So either way, I think the computer's going to accept either one of these. So this is factored over complex numbers. All right, so yeah, essentially what those two phrases mean. So when we say factored over the real numbers, we just mean factor it as much as you can down to linear factors using real numbers. And when we say factored over the complex numbers, we mean we want to break it down to linear factors using complex numbers too. So here we go, we've done it.